Hello and welcome back to the Coking.com channel. I am Evan Hyde, your host, and I am here on the shop floor today with our friends from MIAM and Kanan Fontenot. So Kanan, would you introduce yourself briefly to our audience?
My name is Kanan Fontenot, and I'm with MIAM North America. We're a specialty manufacturer of severe service valves and automation.
Perfect. Thanks, Kanan. So I would encourage you to check out our other video from MIAM where they talk about the pieces and parts of this valve. So if you haven't watched that video, go back and watch that video, because today we're going to be talking about troubleshooting these valves. And despite what anyone would tell you, coking people are very good at breaking things. So we thought we'd do a quick little primer for you guys at home about how would you troubleshoot this valve if you had to do so in the field.
Sure.
So, Kanan, can you kind of just give us a quick rundown about the parts of the valve that potentially can get damaged or wear out and how the operators can perceive that?
Of course. So the lift and turn plug valve actually is very simple and fortunately very rugged. From the bonnet down, essentially all that sees process is the body with the integral metal seats, and interior of that is the metal plug and stem. That's it. So there are no loading, seats, springs, anything of that nature.
Just two parts.
Two parts, plug and a body.
Okay.
That's it. So from there, we've got the bracket or fabricated connector from the bonnet to our gearing system. The gearing system actually creates the lift and turn motion that's required by the plug, and then the gear head on top. And of course, we do a lot of automation, actuation, a number of different types, even hydraulics. So should you find yourself with a malfunctioning valve in the field, which can happen.
So how would it present itself?
Well, typically what you'll find in a coker, the most common issue that we've seen would just be failure to fully rotate. So over a long period of time, if you were to over torque or damage the gearing system, that could present a failure to operate properly. So fortunately, the design of the valve itself allows for easy removal and replacement so that you can maintain your process flow and continue to stay on the run as opposed to shutting the unit down.
So if this thing were to wear out over time, would it get stuck in the middle, or would it fail to move up or down? How would the operators perceive that?
Generally speaking, it could be either, but typically what we find is if it has been over torqued, you might break the gear. It might just simply stop motion altogether. But normally the lift and drop are pretty consistent.
Okay.
They usually are working. It's normally you're going to see some kind of issue in the rotation
transit
phase.
Okay, so the operators, one of the things we always recommend is that the operators don't just believe your instrumentation. When you ask this valve to move, you need to put eyes on it. This little lever right here, it'll lift, it'll start transiting, and if it starts to get a little sticky in the middle, you might want to tell somebody, hey, there's something maybe wearing out.
Yeah.
Here's catch it before it actually completely fails.
Yeah, you may see, if you have an electric actuator, which most folks do, you'll see some strange torque spikes in your data.
Another thing, good point. You got to monitor the torque.
Yep.
So get that torque into the DCS, get it into a laptop, analyze it periodically, because the torque curve should be like spike up for the breakaway, relatively stable in transit, and spike up for the seat.
That's exactly.
If you see anything in the middle, that's no bueno.
Yes, exactly. Because of the simplicity of the valve design internally, when the plug is fully elevated, it is free floating. So any kind of torque spike that you're seeing in that transition, that rotational phase, would be an indicator for certain. You've got something going on.
Got it. Interesting.
So
let's talk about these two parts. They're purged with steam. So this is one of the steam purges here. And when the valve is in its seated position, there should be no steam consumption, right?
That's correct.
So how, if you did start to see any wear of the body or the seats, you would be getting steam consumption in times when you're not supposed to.
That's correct. So when the valve is fully seated closed or fully seated open, the purge steam should be isolated and stagnant at that point. And normally normally most folks have some gauges on their steam lines. Mm-hmm. You'll see that steam gauge start to flutter and maybe not hold pressure, essentially. So we do have a number of purge lines. So you have one on either side and typically one directly at the bottom. And then, of course, you see this right here. We have a tangential purge capacity. It really creates a cyclone
swirling effect
at the bottom.
Interesting.
So, as you mentioned, if you have steam leakage over the course of time, it could possibly allow for collection of coke and solids into the cavity around the plug, which also would certainly create possibly torque issues or improper sealing when you go to seat off, seated open or seated closed.
Yeah.
So, one, it would be important to kind of monitor your steam. I would recommend that with all coker valves, of course.
I like that concept, though, of secondary indication. We teach a lot of that in our operator training, is that, okay, so you maybe can believe the instruments, but what external to that can you look at? So I just want to kind of reinforce that point that you mentioned, which I think was good, is that this line, it should be at header pressure when everything's good. And then when the valve transits, it should drop to more or less process pressure. And then it should come back to the header pressure. And this is something the operators can do their verification on at a completely independent variable that has nothing to do with any of this equipment.
Yep.
So that's
exactly right.
That's a good one. And then also, I think for those of you in the audience who are more familiar with other valve designs that have some sort of continuous purge, we often recommend that they do a periodic steam purge survey of their valves to make sure that the steam purges are hot and they're flowing at the appropriate time. The inverse would be true here, right?
Correct.
So if the valve...
Yeah, if this valve is seated open or seated closed and you're flowing steam through there like crazy, we've got an issue with the seating capacity of the valve itself. Mm-hmm. Probably need to put it on your list to do some maintenance
sooner rather than later.
Yeah.
Right? Interesting. Well, so we've covered sort of a bit of a description about how you can monitor the health of the body, how you can monitor the health of the actuation system. Is there anything else that comes to your mind about something go wrong with this style of valve?
Well, I would mention further about the gearing system itself. I say all the time, these folks making coke, it's such a severe application. The possibility of damaging equipment or premature wear and failure is always there. Mm-hmm. The main thing for most folks is to stay online. So we've designed this one in such a way to where we can actually break this split coupling.
Okay.
Next the intermat to the stem of the valve. This can actually be disconnected. You tighten down on the packing and lock the plug down essentially in its location. This can be disconnected. This, as soon as you break these flange bolts, this entire unit can be removed and another one can be placed on and you can get back running. If in fact that's the mechanism for failure.
One thing I don't see on here, whereas we typically would see at the actuators themselves or the gearboxes, I don't see any grease ports on here. Is this something that needs to be regularly greased?
No, actually the valve, the intermat body is completely sealed, top and bottom, and completely packed with a high viscous, high temperature grease. So generally you will not touch this thing.
In between rebuild cycles.
And actually we go, depending on the coker unit, its proximity to salt water and all kind of other things that come into play. Generally speaking, we don't actually, our PM for this after a full campaign of 5 years is to cycle it. You kind of hear, put your hand on it. If it rotates and runs smoothly, you don't hear any kind of unusual noises, metal grinding, anything of that nature, it's usually going to be good to go.
Okay, great. Well, I appreciate your time, Kanan, and giving us a rundown on how the operators could perceive the health of their valves. So I want to say thanks to our friends at MIAM and thanks to you guys at home for watching. This has been another coking.com video. Come back to our channel for all things silly coking. And thanks a lot, sir.
Thanks, Evan.
And we'll talk to you again soon. Thanks all.